So if we look at solving a system of equations using the elimination method, remember this is one of two methods and you get to pick which one you want to use. By elimination, what I mean is that I'm eliminating one of the variables. And we eliminate one of the variables by having the leading coefficient be the same number but opposite sign. So for example, if we look at this example, I could eliminate these two x's if I could somehow make this x a negative 3x, because 3x minus 3x is 0, so they would cancel. Or my other option would be to eliminate the y's. If I have a positive 2y down here and somehow I could make this a negative 2y, well, negative 2y plus 2y would in fact cancel. So I'm going to eliminate the x's first and show you what that looks like. So if I want to make this second equation a negative 3x, what I need to do is I need to multiply the entire equation, so use parentheses, by negative 3. And what that looks like is my first equation is not going to change, so 3x minus y equals 2. But my second equation is going to become negative 3x minus 6y equals negative 30. Make sure you distribute that negative 3 to everything. Now, these x's do in fact cancel, and I end up with negative 7y equals negative 28. Oops. It's a negative. And then y equals positive 4. So remember, when we do a system of equations, these are two linear equations. There are no exponents here, so we know they're linear equations. And I'm looking for that one point where they cross, if they cross anywhere, but in this case they do. So it's going to be positive 4, and I'm only halfway done, so I have to find my x value. All I did was solve for y, and I find my x value by simply plugging this y equal 4 either in y in the first equation or the second equation. It doesn't matter. I'm going to choose to pick this first equation, but I could have picked the second one. So I'm going to get 3x minus 4 equals 2. 3x equals 6, so x equals positive 2. So my x value is 2. Let's go back. Make sure you're always taking the time to check the answers. So I'm going to plug in 2 and 4 for x and y. So I'm going to get 6 minus 4 does in fact equal 2, so it works in the first equation. And 2 plus 8 does in fact equal 10. So see, it only takes a second to check it. Please don't be lazy. Please take the time to check your answers. So this, in fact, is the final solution. Now, in this example, I chose to eliminate the x's, but I could have just as likely chose to eliminate the y's, right? And if I wanted to eliminate the y's, what I would have done is I would have multiplied this very first equation by positive 2, because if I multiplied this minus y, or this negative y, by positive 2, I would have ended up with a negative 2y and a positive 2y, which would have in fact eliminated. But you need to make sure that that positive 2 gets put out front in parentheses. So I would have had 6x minus 2y equals 4, and then the y's would have canceled. And that's it. And lastly, sometimes with the elimination method, you can't just multiply one equation to eliminate the second equation. So for example, if we look at this equation, I can't just multiply this first equation by something to turn this x into a negative 3, and I can't just multiply this one by something to turn it into a negative 2. Nor can I easily eliminate these y's, but it's okay to multiply both equations if you need to. So I could, for example, I could multiply this first equation by negative 3, and I could multiply this second equation by positive 2. If I did that, can you see just by the x's, I would get negative 6x for the first equation and positive 6x for the second equation, which would in fact eliminate, right? Or I could have let's cross these out. I could have multiplied the first equation. If I wanted to eliminate the y's, I could have multiplied the first equation by negative 5 and the second equation by positive 3. And in that case, I would have ended up with negative 15y, and on the bottom I would have had positive 15y, which would have in fact eliminated out when I added the two equations together. So just recognize that sometimes you have to multiply both equations by some number in order to get one of the variables to eliminate. And don't be afraid, because sometimes you're going to have to multiply by a fraction or a decimal, and that's okay too.